project title is Intelligent Information Extractor through Artificial Data Analyzer Mechanism in Electrocardiogramic Data. Objective: ECG electrocardiography is the recording of the electrical activity of the heart. It should have a systematic approach to interpreting the ECG. You can able to identify ECG abnormalities. In existing, it does not tune up the image before processing as the noise percentage. It misleads to the diagnosis report. But in proposed, an image validation of histogram check is formulated to rectify the noise and validate the image. The validated image has been measured with its height and amplitude to measure the abnormalities using XML ontology. It overcomes the conflicts faced in the existing, and it performs in terms of time and accuracy, has been visualized graphically. To improve the understanding of ECG diagnosis and develop a more accurate ECG diagnosis report. Using histogram process undergoes various kind of checks to overcome this conflicts, to validate the image. Then this is requirements, software requirements, hardware requirements. Platform .NET, database SQL Server 2008 R2, processor Intel processor, speed 2.2 GHz, RAM 2 GB, hard disk 160 GB. This is architecture diagram. First, load the digital input ECG image and converted into digital image. Image processing. The analysis and manipulations of a digitized image, especially in order to improve its quality, to convert an image into digital format. After loading the input image, then ECG sample variation will be performed. It's like normally heart beats or normal, fast, slow, irregular heartbeats like. So yes, sample variations will occur. After then, the histogram validation is performed. This gross validation. It is a graphical representations of tonal distributions in digital image. It plots the number of pixels. It analysis of input data, which will be validation from the condition. Then ECG amplitude analysis. This is used to grayscale conversion. After the grayscale conversion, the ECG amplitude analysis will perform. Then XML ontology. XML ontology is behavior of disease, or its nature of being, its security purpose to use. In this code is the data are encrypted in this format. After that we have After that, I have to decrypt that code to get the um, exact data from that ECG image. I mean, to get the exact output, to display the text based output. It will automatically diagnose the report. This is automatic report. The final report is generated based on XML schema to match the type of diseases based upon time interval and amplitude of ECG. To use of this project, to improve the understanding of ECG diagnosis and develop a more accurate ECG diagnosis report. The validation data are compared with the previous data using ontology. Finally, cardiac abnormalities will be detected and ECG report will be generated automatically. Thank you. To implement of this project is to diagnose the ECG report. In this project, to improve the understanding of ECG diagnosis and develop a more accurate ECG diagnosis report model. Let's see. First, load the image. Now I have the digital image of ECG report. So choose the digital image. Proceed to next step. If the digital image is not valid, pictures not satisfied in color extraction, should not taken for our process. So see here, this input image is a valid image. Please go ahead with processing. In this project, I have 5 modules: image validation, image tune-up, grayscale conversion, image segmentation, image analysis. This is image validation. Histogram validation is to check whether green, blue or red, green, blue. It is used to check the colors. Next, move on to second module. Proceed to object extraction. This is second one. To improve the quality of that digital image, what I choose in that image, I just improve the quality of that image. This is that I improved that. Tune up image with enhancement as quality is performed for perfect image processing. After then, view that image. This is that quality of image. Next, grayscale conversion. Another module. Grayscale conversion is used to identify the exact pixel. Grayscale conversion is the black and white color. Let's see. See here. It will change its black and white color. See. This is grayscale conversion. Then only we predict the exact pixel to get the accurate data from the digital image. This is black and white ECG report, digital report image. Then move on to fourth module, image segmentation. Image segmentation, how to segment the set of images to segmented. During the segmentation process, the ontology generation is performed. It has different classes or database, something else. Let's see. These are the image segmentation. First, fetch segmented images. I have to fetch the segment wise. This is the first segment, second, third, fourth. One image I have to fetch 4 ways to fetch the image. Then this is XML ontology view module. This is the security purpose. The exact data will encrypted in this code. This is that code. Finally, we will see the exact output with the text based. Then move on to individual object extraction. This is the segment. This is the each of the segment 1, segment 2, segment 3 to fetch the segmented image. Then individual object extraction is in each individual segment I have x-axis and y-axis value. So first set of images is this, second set of images is this, third set of images is this, this is fourth set of images. Let's see here. This is that. After these 4 set of images get the x-axis and y-axis value, then you have to retrieve the data like one by one. First retrieve the data, first set of images. It will take more time. So see, the cursor is blinking. This is loading. If you know means you just click here to see. It will take few minutes based on PC. Then second retrieve. The second set of image has to retrieve. It's loading. See here, still it's not coming here, so it's still loading. Yes. Then third retrieve. The third set of images I am retrieving. Then fourth, like this. These 4 retrieve set of images, I got clear data to get the exact information about the digital ECG image. Let's see. It's loading. Yes. This is fourth retrieve. It's retrieving. This is the final retrieve. We have one image. In that image, I have to segment it 4 set of types, 1, 2, 3, 4. After that, I have retrieved one by one, first, second, third, fourth. After then, click filtered identification. After I retrieved these 4 set of images, then filter the identifications with ID and x-axis, y-axis with exact curvature axis. Loading. This is data extraction to extract the exact data using this data extraction. After we get used to fetch the data extraction, after we fetch the data to come this side, click this. See here, this is curvature value, x-axis, y-axis. You have to fetch it and retrieve it here. Same as second, third, fourth. Likewise, these are the y-axis value of set of images, second set of images, third set of images, and fourth set of images. After that only I get exact text based output. After then move on to last module, image analysis. Yes, it's analyzing image analysis and extraction module. Yes, this is analyzing 4 set of image, 4 set of segmented. This is that. Finally, fetch information. This is that. What does this means? Fetch information is this output. We have retrieved all the set of 4 set of images, 4 set of 4 segmented of images. Retrieve it and then image analysis and extraction to extract the data. Let's see, fetch information. This is the output of this project. You just see in that digital image arrhythmia, rapid, slow or irregular heartbeats. This disease has occurred in the digital ECG report. Remedies includes here this is that ECG is the recording of the electrical activity of the heart. It should have a systematic approach to interpreting the ECG, and you can able to identify ECG abnormalities. In existing, there is no image validations or image segmentations. So in proposed, image validations of histogram check is formulated to rectify the noise acquired in the input ECG image. It overcomes the problems of false predictions of previous existing of syndromes by validating input image using histogram technique. This is the output, text-based outputs. Thus, the computerized ECG recorders will detect the pathological conditions by utilizing frequency information. This is the text-based ECG diagnosis report. It means automatically